So hello everyone. Here we will check how does memory allocation happen in Win32 applications. I mean to say that Windows applications, when we compile any program in Windows, that called Win32 applications. So let's check. We will check some calls using some call stacks because malloc function directly we cannot see what is happened beneath the malloc function. Under the malloc function, any logic happens, Microsoft hides that because it is his implementation of malloc. We just basically use it, but we cannot see what happens under the malloc. So let's go to the Visual Studio and we'll see. We'll open a folder for our experiments because this is my one of the project in the jig. You can see here. Now, okay. Now here I will create a here not here. Okay, here I will create a program called malloc x.c. Basically malloc experiments in the short. Okay. Now I'll zoom that you can see properly. So I will just call one header called standard lib.h. This is the header where we can import malloc function. So now our main function this is. Here we'll just made a integer pointer. Just going to make a integer pointer that we can see what happens when malloc calls by any program. Let's see. So here we just create a memory on the heap and just freed it. Nothing will happen on the with the a variable. Just creating a variable and free it. Okay. Let's see what happened under the malloc function. So this is a malloc function definition. You can see void or this like here malloc function returns void star because it allocates memory of the any type. So void type is the void star can contain any types of memory. Just basically for that malloc function returns void star. So we will just convert into our memory that we have give integer size of integer. Size of integer means it will 4 or something 3 like that. So it is the size of the integer type. Now you can see the size of the integer size is 4. So it just give malloc function 4 and malloc function done that it ask your OS that we need 4 bytes of memory. Can you give me? Also it can be null. Here is no guarantee that malloc function is always return a valid memory. It can be null. It can be null. Because it is not possible by malloc function that every time he will give you memory. It just asks computer or your OS that the OS will give you some memory for this process. Nothing other than that. Okay. So here you can see our malloc function, but here you cannot see the logic under the memory malloc function. So it is not possible to see the malloc logic under the malloc function. So we have just done a alternative way, that we have compiled our program. We have compiled this program using debug information. So we have just compiled it using debug information, so it can contain it will contain the debug information and the function signatures only. I mean to say function's name, because in the C language everybody knows that, or you will also know that in the C language, when we create a function, we will give a name, and that name is fixed. When the compiler also compile that name, the name will be fixed. Whatever we have give, the name will contain in the assembly or the object file also. Okay, so it is not possible that we will change our function name and assembly will call other function name. No, that not happened. So let's see. Now this is our experiment file. So whatever I done, I have simply copied all the call stack and paste it here. Okay, let's see, you can see. So it is time of calling malloc. So our main function starts here, and after then that we have just called malloc function. No other function I have written here, you can see. Okay, so malloc function is just basically a malloc base function under the UCRT base.dll. So it is a UCRT dot base.dll. It is a runtime for Microsoft to run C applications. It is just a C runtime. So everybody knows that C has a runtime, some runtimes in the Windows, that MBCRT and UCRT. So it's used UCRT. Here you can see. So it's just called malloc base function under the UCRT base. Now malloc base function is it takes from memory from the OS and gives you, but it not directly. It's checks some security checks. It done some security checks and also done some also gives some what we can say, uh, some properties to our memory, so we can access to it. So let's see. Then it called RTL allocate heap. So it's a function, basically it allocates memory on the heap. This function allocates memory on the heap. Whenever we need to allocate heap, because in the C it does not mean that whenever you called whenever you run a program, it will only one memory heap. It can contain multiple memory heap. So here you can just see here. So I'll just search here heap allocation in C in C in 32. So this is just basically for Windows applications. So here you can see Microsoft also told that we can allocate heap using heap alloc function. Here you can see. So whatever it's so you can see that this function succeeds return the value of a pointer to the allocated memory of block. So this function gives you the memory whatever you allocated. Okay, and what need to allocate to allocate memory using heap alloc function. So here you can see the first parameter which takes a handle of each heap, which takes a handle to heap. So in the description you can see a handle to the heap which the memory will be allocated. This handle is returned by heap create or get process heap function. So it just basically told that you have need an heap, there we will create your memory. So our program can handle multiple heaps. So let's see one thing. Here is a heap create function you can see. So this function told that we can get heap from the get process heap or heap create. So heap create, or the description of heap create, creates a private heap object that can use to calling a process. The function reserves space in the virtual address space of the process and allocates physical storage for a specified initial portion of this block. So it's told that it's create a private heap. I have told you that we have multiple heap, so it will create a private heap which can used by your process to create destroy your memory. So here you can see this function succeeds return the value of the value is a handle to the newly created heap. So this was just basically creates an heap and to give it to you. Here you can allocate memory. Okay, now let's see one thing, great process heap. So I will going to close this tab, and so get process heap. This function give the default heap. So here you can see every function when we call malloc also create a heap where program basically used to allocate memory. I mean to say this is the default. When program runs, this will be created by your compiler. This is default. Every process has its own heap which is default. So here you can see it's the default heap of the calling process. This handle can be used in the subsequent call to the heap function. So just basically this give you the default heap, and you can call from other call all the heap functions like destroy, create, free, this like functions in this heap. Okay, so let's see. So I just close this tab, and also you can see here more other heap functions. So we'll ignore this. Let's see our program what says. So it just calls RTL allocate heap. RTL allocate heap it's called by your default heap. So or other than that, it is not a Win32 API function. It is under the your DLL function, your module function, NT module function. So NTDLL is a module which contains this function. It is not open to other users, so you can just it is not easy to call this function from your program. This is a system function. You can say this is a syscall. Okay, now let's see one thing. Now EWT lock trace event. So this events, this is basically a function. This simply logs all the events, whatever you are calling functions and whatever you are changing in the process. This tracks all the events. Okay, now we will not go to the deep in the this function. This is just basically uh, setting the properties like that. So RTL register secure memory cache callback, it is also a property setting function. Just like that, you can see it is called in EWT lock trace event, so you can understand. RTL unlock heap. This is a function which unlocks heap to use by your program, just like that. Because when we create something memory on the heap, this is default by default, that is private. I mean that only can used by your module. Module means to say DLL or your program, not other programs which attach to your process. So just basically unlock the heap. Now also another function is called in the register security memory. I have previously told you that it is just setting the properties to the heap. Enter physical section also another function to setting these properties, so we'll ignore that. Now allocate heap, it is also setting the properties of the heap. Now under the allocate heap, again we can see the EWT lock trace event. Now just come back one step and another function called in the register secure memory cache callback function. So you can see that RTL set user value on the heap. So just basically setting the properties, and now it's end. Not now, it's going to end. Okay. So one by one call stack will finish and program will exit. Now here what happened here, the calling this is the calling of the free function. Okay, so it's the call stack when the free function is just basically called. So free function is not a free function, it is a free base function which is under the UCRT base DLL. Now it also calls the whatever you create, so destroy function will be called. So here you can see it is just freeing all the memory and its properties. So this is freeze the heap, and this is gives the current process ID, so all the heaps can be accessed by this free function. And here all the properties cleanup going on. Now again log the trace events, and again all the properties will deleting. Now you can see all the properties cleaning up. Now at the last all the call stack will finish, and our program will going to at the finish moment where the return will happen. Now one thing you can see that at the before of the return, or you can say that when return happens, just happens, program is going to finish, program triggers this function, and in the call stack trigger this function. This is run by operating system, not by user. So this function basically a cleaning runtime. I have told you that we have a runtime for our C functions. We have runtimes for our C functions. So it is basically it is a runtime which cleanups the memory at the last moment and checks all the memory errors. Whatever we have not cleaned or double freed, that's like all the vulnerabilities and all the memory related errors. It continuously checked by these functions. Okay, now you can think how this function will know that we have done a memory error. So this is the function which tracks all the events we have done in our program, memory related basically memory related things. EWT log trace event, you can see this function is a masterpiece function. This function this function tracks all the events, how whenever we have freed, which memory we have freed, how many times we have freed, all the events tracks by this function. And this function, and when we exit from the main we exit from the program, this function will give a report to the OS that these programs will done this errors, and OS will do some cleanup, or if there is any critical fault, then OS will give an error. Just whatever is going on the under the OS. So we cannot explain everything here. You can just simply copy and paste here and search whatever function you will need to know. So you can learn from this documentation. Everything is everything told here by properly. Everything told here properly, whatever you need. So here you can see where these functions all are declared, or what is the main uh, compiled binaries of these functions, because these functions are not implemented in the header files or not implemented in publicly. It is a private function which gives us a API to work with that, just like this. So it is called Win32 API because all the Windows functions, Windows have implemented many more functions to working with GUI, console, everything. Windows create many more functions, and Windows gives us some of these APIs to working with that. So it's just basically a C function, C header files. On you can see the name of the header files here. Just import the header file and link with this library file or whatever you want, library or DLL, and you can make program using this function. So here we will going to end. Now this is a simple experiment of the malloc. So thank you for watching this video.